Okay. So as I mentioned before, you do the lab first, and then the lecture comes afterwards, which is why the lecture's not posted till today. But this class is Physics 502, Science Investigation. This will be your day one. So a regular science class is you're taught theories, laws, and relationships. So let's say Physics 213. You're taught various theories, Newton's laws, inverse relationships, say, between kinetic and potential energy. That's usually a normal science class, and then you use that knowledge to solve problems. So generally, in a normal science class like 213, as I mentioned before, you'll learn about, say, conservation of energy, and then later on the next week, you'll do an actual lab with dealing with conservation of energy. That's how normal, or rather more traditional science classes are taught. This, however, is an inquiry science class. It's fundamentally flipped, if you will. You first do experiments. Based off of those experiments, you're going to build a working model based off of your experimental data. So the data creates some sort of basic model that you can then later on use to predict results. And then later you have the lecture reinforcing your experimental knowledge that you picked up. This is kind of similar to the modeling curriculum that you sometimes hear thrown out in your education classes. But yeah, that's basically the gist of how this class works. Now, how science actually works is, you generally, before you conduct an experiment, you'll have an idea about something. Like, what if this happens? What will this result in? So once you have that idea, you end up conducting an experiment to figure out, well, was that idea even valid? And then based off the analysis of the data from the experiment, you try to develop a relationship, or at a minimum, you're going to see if one exists. Then you're going to apply that new knowledge to solve problems. And that's basically how science works. So this is kind of closer to, I would say it's closer to how science actually works in an inquiry class as opposed to a traditional class, just because you're using the data to build some sort of model and to create some sort of relationship based off of the data. Because a lot of times with science, someone has to invent it. Someone didn't really understand gravity until they looked at the results and said, okay, well, this is kind of weird. There's got to be something here. And that's kind of how you make leaps and bounds and figure things out in science. And this will hopefully give you an appreciation, or at least a basic appreciation, of the scientific principles and how they're developed. Now, from the first lab, they talked about properties of matter. A property is an attribute, quality, or characteristic of something. As I said before, the property can be really anything. You could use, I use the example prettiness, but technically I guess that is a property of matter. Not really a scientific one, but you could say it's a property of matter. The property is just a word or term that we use to describe something. It basically allows us to categorize it. Some are subjective a bit, like luster. You do have a chart from that, but if you don't have some sort of chart to work off of, people are going to see things differently. Color could be kind of subjective as a property of matter, because people, for example, my right eye and my left eye see purple a little bit different. One of them sees it a little more blue than the other. So some of the properties can be a bit subjective. Others that are based off of numerical data are clearly not. They're a lot easier to use. And as I said, it doesn't have to be scientific to be necessary to be a property of matter, but to be a scientific property of matter, it does. Well, what is matter? It's a substance of material that occupies space and has what's called rest mass. I say rest mass because photons, the units of light, they have energy, clearly, because there's if you put like let's say a bacteria, okay, the bacteria is going to die, but we're assuming it's a super bacteria that can survive in the vacuum of space. If you put a bacteria less than, say, a micron out in space, it'll actually get pushed by the solar winds. And solar winds are essentially photons, which are massless, and they can actually push that piece of bacteria, that super bacteria that's somehow surviving the vacuum of space, right out of the solar system eventually. So they have no mass, yet they have energy and they have momentum. So what rest mass means is basically, in this case, not photons. Something that actually has a measurable mass that we could, in theory, if you have a scale, you can actually measure the mass. There are many properties of matter. I could go on forever talking about it. And scientists are constantly adding or refining to the list of what properties of matter are. The most recent one that I've heard of is excitonium. Basically, this is kind of an artist's depiction of it, but with excitonium, basically you have a photon, a unit of light that comes in. It will hit one of the atoms, and it will cause the electron to leave, if you remember from chemistry, your valence area and jump up to the conduction area. So if you remember from chemistry, the conduction electrons are kind of at the surface and kind of move around along the surface of a conductor. Hence, they're called conduction electrons. And if you haven't had chemistry and like, what the crap is he talking about? It's all right. I'm just trying to give you an example. You don't have to know this specifically for the class. You'll be fine. But I'm just trying to give you an example of a new property of matter. But anyways, when that little electron jumps up the level due to the photon hitting it, it leaves behind a hole. And this hole is positive. So other electrons rush in to be attracted to said hole. And this, on a larger scale, it actually fundamentally is a different property of, or literally it's actually a different piece of matter. And so a different state of matter. I don't know why I couldn't think of the word. So that's kind of a big thing that a lot of physicists and physical chemists do, is they're always trying to look for different states of matter, different properties of matter, because in this case, the excitonium occurs in superconductors, and superconductors are unique in that if you have a superconductor, you can transfer electric charge but not have any loss of energy, i.e. saving money. Yay. So that's why scientists look at these things. Types of property of matter. There are intrinsic properties. That's an integral or essential property of matter of the object itself. If this property changes, then the object itself will change. An example is mass. If I go on a diet, then my mass changes, and I myself am actually changing because I take up less space. Other examples are density, volume, shape. There should be a comma there. Wow, I really forgot a lot of commas there. Interesting. Oh, I could do this. Let's see here. I've not used Windows OneNote yet before for this, so this will be my first time using it. Let's see if it lets me. No! There we go. There we go. Now we're good. Shape, texture, melting point, material, hardness, etc. Extrinsic are not essential to the object itself. It comes from outside the object. Examples include like location, temperature, exposed surface area. Location and temperature are probably the more, I would say, a better example. That's because if I move my physical location from here over to Jabara 110, which I'll be here in a little bit, I'm still the same person. It's just I changed my location. Temperature generally is also going to be an extrinsic property. I say generally because, well, think of an water. Well, liquid water, if it has a temperature swing of 100 degrees downward, it's going to freeze. So within reason, temperature could be an extrinsic property. So there is a bit of a gray area. So in your homework, if you're picking out something in the gray area, you're not really sure, just explain it, and as long as it sounds good, I'll still give you credit. But yeah, there are some of these that do kind of flirt with the gray area of what is extrinsic and what's intrinsic. Quantitative is much easier. It can be assigned a numeric value. It's generally going to be something that one can measure on some scale and that you can calculate. So my mass, I weigh myself at FASA. That's my mass. That's a quantitative number. It's a property. Characteristics is a lot easier of a property to remember. It's basically the same for all objects made of the same material. They're not going to change for a given material under normal circumstances. Density is the most popular. Yeah, for water, as I used in an example earlier, water does kind of vary density based off of temperature, but not by a lot. So for things like iron, for the most part, it's going to be a characteristic property. Melting point is a characteristic property. You'll learn later specific heat, electrical conductivity. Basically, a characteristic property is something that you can look up in a search engine and figure out an entire table of this. Table of densities, table of melting point. If it's got a table, it's a characteristic property. It's pretty simple. At least in my head it is. And the last thing we talked about was operational definitions. So a normal definition is going to define something, whereas an operational definition is a detailed description of the process used to measure or calculate something. So why this example popped in my head, don't know, but in this state we don't have to do it, but I used to live in Tennessee for a year, and with jobs they used to have to make you do a drug test. Well, a normal definition would be a drug test would just say what the drug test is. Well, you pee in a cup, essentially. An operational definition is going to literally give you instructions on how to pee in the cup. So when you got the drug test for getting any job, you would actually see instructions on the wall in the bathroom on how to pee in a cup. Not sure why you need instructions for that, but I always found that a little bizarre. But yeah. That would be an operational definition to explain the process. So you can think of it as a recipe. And so basically that if you're the first person to take a drug test and you document everything that you do, the next person behind you can follow your exact example and produce the same, not the exact same drug test, but produce a drug test just like you did. So that's what an operational definition is. It's just kind of like a recipe or a procedure. It's a little bit more detailed. So this is it. Most of your first few lectures are going to be short, maybe 5-10 minutes. They'll progressively get longer as the class gets a little bit more complex. But the entire first unit, there's hardly any math. A little bit, but not a lot of math. And so you're not going to be dealing too much, you're not going to be watching too long of lectures. Not until we get later on, and even then, I don't think my lectures ever go more than 30 minutes in this class. Most of the time is spent doing the lab. So, all right, well, I will get this posted, and we'll see you in class probably in a couple hours.